Today we'll be learning how to find the sides of a triangle using the trigonometric ratios for sine, cosine and tangent. So just a bit of a recap on our trig ratios. We had before that sine theta was equal to opposite over hypotenuse, your cosine was equal to the adjacent side over hypotenuse, and you had that tan theta was equal to the opposite over the adjacent. And the way that we remembered that was with our SOHCAHTOA. So you might not have remembered it just yet, but it's something that you'll just continue to use and hopefully it sticks in your head after a while. But for now, we're going to look at solving these types of problems where we have an unknown value in our triangle. Now there are two types of examples, and I'll show you them both, but basically it's split up into unknowns on the top of a fraction or an unknown on the bottom of a fraction, and I'll show you how to go through both. So they're both really important and they're both very similar. It doesn't matter whether you're using sine or cosine or tangent, it doesn't matter at all. It's the same steps, you just have a slightly different looking equation. Alright, let's have a look at this one. So we want to find x. So our very first thing we need to do is we need to decide which one am I going to use. Am I going to use sine, am I going to use cosine, or am I going to use tangent? So what I have is I'm going to label my sides. So I have my hypotenuse, I have my angle over here, so that means this side over here is my opposite, because it's on the opposite side. Okay, so then I have a H and I have an O. Alright, so which of these three cases would I use? I had sine, which was opposite and hypotenuse. Oh, I have the hypotenuse and the opposite. So I don't have adjacent or hypotenuse, I don't have opposite and adjacent. I have the hypotenuse and opposite. So that means I have to be using this one here. So let's write down an equation that involved all of this. So I know my angle this time is 61, and that's equal to my opposite over my hypotenuse. Right, I know what my opposite and hypotenuse are, so I have my x on my hypotenuse, which was 9.6. Now if I want to find x by itself, we use our linear equation skills, and we want to go, okay, times by 9.6 on both sides. Alright, so this 9.6 on this side, we normally put out the front. Alright, because we are not timesing 61 by 9.6, we're timesing sine of 61 by 9.6. And this is then equal to x. And if I put that in the calculator, I'd go 9.6 times by sine of 61, and that is going to be 8.396 is equal to x. Alright, or x is equal to, if we were doing two decimal places, 8.40 centimeters. And that would be how you would solve it. So if I had a unknown on my top, I times my sine value by the bottom of my fraction. Alright, let's have a look at what we would do if we had sine on the if we had an angle on the bottom of a fraction instead. So let's have a look at this one here. Again, our very first step is to label each of our sides. So I have my angle here, and that means this is my adjacent. This is on the opposite side, so that is opposite. So do I have an opposite and hypotenuse? I don't have a hypotenuse. I don't have any values for my hypotenuse, so it's not that one. So cosine, adjacent and hypotenuse, well, I have an adjacent but I don't have that hypotenuse again. I do, however, have the opposite and the adjacent. So I can use tan in this case, or tangent. So tan of 41 is equal to my opposite, which is 7.8, all over x. Now in the last problem, we had x was on our numerator, whereas now x is on our denominator. So if I was to rearrange this, right, I could times x up here, so I would get x times by tan 41, and that's equal to 7.8. Alright, but I want x by itself. So what do I do if I have a number all by itself here, or a value that I want to get all by itself, and I'm multiplying by something, well, I should be able to divide by tan of 41. Right? Just because it's not a nice looking number doesn't mean I can't do it. So I'm going to divide by tan 41, and what I end up with is x is equal to 7.8 over tan of 41. And I can put that in the calculator, and I end up getting, so 7.8 divided by tan of 41 ends up being 8.97. So x is equal to 8.97 meters in this case. So hopefully you can see the difference between whether you have an unknown on the bottom of a fraction or if you have unknown on the top of a fraction. Right, it's two slightly different set of steps, but they're really the only two things that you need to be able to do when calculating sides using your trig ratios. Best way of practicing this is literally to do just that, practice.